This is the notes for section 6.1. This lesson is on adding and subtracting polynomials. So before we get started with how to add and subtract polynomials, what I want to do is just kind of review a little bit of vocab. So remember, we have defined a polynomial before as something that can be written in the form a sub n, x to the n, plus a sub n minus 1, x to the, I can't write today, x to the n minus 1, down to a sub 0. This polynomial is actually the sum. Another way to think about it is a sum of monomials. And you might say, oh, well, that's garbage. What's a monomial? You haven't defined that. Well, okay. A monomial is just something of this. So we just have a bunch of leading coefficients and variables. And again, for a polynomial, these a's are real numbers, and these n's are positive integers. And the same thing here for these monomials is that these a's are real numbers, and these n's are positive integers. So you can just think about a polynomial, the sum of a bunch of monomials. And you're going to say, okay, yeah, so what? And the reason we do that is just so that we can define the degree of a polynomial a little easier. Is what we do is we define it in terms of the degree of a monomial. So the degree of a monomial is that exponent. And we say the degree of a polynomial is the largest degree of the monomial terms. So what are we saying here for the polynomial 3x to the 4th plus 2x to the 7th minus 6x plus 18x to the 3rd. The degree of this polynomial is 7. It's the biggest exponent on the terms. That's all we're saying. So it's really quite straightforward, the vocabulary, right? Also worth mentioning is the leading coefficient, and that's the coefficient coefficient of a polynomial is the coefficient on the monomial term with the greatest degree. And that's a whole lot of words to say that the leading coefficient, for example, would be that. It's 2. It's the coefficient on the biggest degree. Okay. So how do we add or subtract polynomials? Combine like terms. How do we identify like terms? Things with the same degree. So, for example, if I did 4x squared minus x cubed plus 2 plus 5x to the fourth plus negative x plus 6x squared plus 3x to the fourth. The things that I would add together that are like terms. These are both fourths. These are both squareds. And these are both, and then there's none of these things have like terms. So, I would say 5x to the fourth plus 3x to the fourth is 8x to the fourth. 6x squared and 4x squared is 10x squared. I have no x cubes to combine, so we just have that negative x cubed. I have no x's to combine, so I have negative x. And I have no 2's to combine, so I posit 2. And then typically we like to write this in what's called standard form, where we write them in descending order. So I have degree 4, then degree 3, then degree 2, then degree 1, then degree 0. And that's it. Let's do another one. Let's consider this one. So 12x to the third plus 5x minus 8x cubed, not cubed, squared, plus 19 minus 6x squared minus 9x plus 3 minus 8x cubed. So my idea here is just like when we subtracted complex numbers. I'm going to start by rewriting this as an addition problem. So I'm going to distribute that negative sign through the second piece. And I'm going to look for like terms to combine. So I have these x cubes to combine, these x's to combine, these x squareds to combine, and these constants to combine. So when I write that, I have 12x cubed plus 18x cubed is 30x cubed. I have negative 6x squared and negative 8x squared gives me negative 14x squared. I have 5x and 9x gives me 14x. And then I have 19 and negative 3 gives me 16. And that's it for that. Okay? So again, doing the adding and subtracting is pretty straightforward. It's just about combining like terms. Let's look at an example story problem. And so what we're doing here is we're doing some modeling of situations using addition and subtraction. So the example that I'm looking at is example 3 on page 274. So this says the data from the U.S. Census Bureau for 2005 through 2009 shows that the number of male students enrolled in high school in the United States can be modeled by the function m of x equals negative 10.4 x cubed plus 74.2 x squared minus 3.4x plus 8,320.2, where x is the number of years after 2005. And m of x is the number of students male students in thousands. The number of female students enrolled in high school can be modeled by the function f of x equals negative 13.8 x cubed plus 55.3x squared plus 141x plus 7,880, where x is again still the number of years after 25, and f of x is the number of female students in thousands. Okay, so this was all kind of given information for you. And we might ask estimate the total number of students enrolled in high school. Well, that should be pretty easy. Total number of students would be number of male students plus number of female students. So if I do that, I get negative 10.4x cubed plus negative 13.8x cubed. That gives me negative 24.2x cubed. And then 74.2x squared plus 55.3x squared gives me 129.5x squared. And then negative 3.4 plus 141x gives me 137.6x. And then 8,320.2 plus 7,880 gives me 16,200.2. And then I could ask something like estimate the number of students in 2009. So that means that x is going to be because x is years after 2005 is the way it was defined. So 2009 is 4 years after. So I just plug this in above, and when I type that into my calculator, I get about 17,274. And the rest of these modeling problems are similar, where you're just going to be adding or subtracting two functions and then maybe plugging in a value to evaluate. That's it.